Back in the 80s, most televisions didn't even have a single video input, never mind multiple. So what did you do if you had 2 or 3 or 4 different devices? So you had a Laserdisc and a VHS, or a VHS and a Beta and a Laserdisc, or a VHS, Beta, Laserdisc, and a camcorder, but only one input on your TV. Well, Radio Shack had a solution to that, and here it is. Anyone that's been around video any length of time knows what this little box is. This was from the era when televisions had one audio-video input. And that was great if you only had a VCR to connect. But if you had other devices, such as a Laserdisc, or, God forbid, a CED disc player, or a Beta and a VHS, or a camcorder and your VHS, or how about all three? How about a video disc, a camcorder, a Beta, and a VHS? That's where one of these little audio-video control centers came into play. So this allowed you to have 4 separate sources and send them to the monitors separately. VTR1, VTR2, your disc player and auxiliary, in that case maybe cameras. And it would allow you to select the output for, depending on what your, someone's got some writing on this thing, depending on what you were using. So your videotape machine number 1, you could send it VCR 2's signal, the Laserdisc or the camera, and the same with VTR 2. You could send it VTR 1's signal, the Laserdisc or the camera. And then there was this processor, VTR 1, VTR 2, disc, and auxiliary, and that was basically worked like the loop through on an audio amplifier. So if you had, there was an actual processor that they sold as well with this, and there's one kicking around here somewhere because this was mine from years gone by. But it would allow, it actually had 2 inputs on it as well, and it would allow you to fade to black or wipe to black, either a square or sides, or I think that way. I think it only went 4 ways. But it would let you wipe to black and back to picture and fade to black, which was kind of cool because back in the days when these were around, we didn't have those audio video mixers that came out after that. So this unit here, basically I was using it as a switch because it allowed me to switch all my different hardware through to one TV that only had one input. And I used this thing for a few years. Then it got kind of delegated to just being a switch for the different devices. I think I had my satellite dish on one of the inputs, and because my TV of the day only had, I think it only had 2 video inputs on it. So this allowed me to switch 4 inputs, and I could record on from any of them. I think I actually used this as the record output. I used the processor out so that I could record from any of the 4 inputs, even though you could do that with the separate ones. But anyway, on the back, this is what we had on the back. We had auxiliary in, left and right audio plus video, processor out and processor in, monitor out, video disc in, VCR 1 in and out, VCR 2 in and out. This one here is totally dead. It got whacked by a power surge, I think 20 years ago. It was 20 years ago. And I'll tell you that story. 20 years ago, they were building a new house. They knocked the house down next to me. It was before my house was even renovated. I was still living in the original house that was built back in the late 40s before I tore it down and renovated it. But they tore down the house next door to me. Sure, unplugged. And built a new house. And the contractor comes up to me and he says, hey, he says, can I get power from you to run my saws and stuff? He says, okay, yeah. He says, I'll pay you. Okay, what are you going to pay me? Well, I'll give you $100, to use your power rather than put in a power pole and, put in a PowerPoint for them. He says, I'll give you $100 for it. Okay, so I get set to give him power. I said, well, I've got a garage that's got 240 in it. And he's like, oh, perfect. That'd be great. 240. That's what we want. And I said, okay, just leave me the cable, and I will connect it. And when I get home from work, I will connect it. Just leave me the cable. Have it terminated in your box. Leave your master breaker turned off, and I will connect the red, the black, the white, and the green wire, ground, right, to the junction box in my garage. And he says, oh, no, you can't do it. He says, it has to be done by my guy. He says, I'll send my electrician over, and he'll connect it. Of course, the next day I'm at work. I was working at the TV shop still at the time. And I couldn't turn the power off to my garage because in that garage I had, was my ham radio shack for one, but I had a freezer. So I couldn't turn the power off. So I told my wife, when he comes over, you're going to have to turn off the power to the garage. And I marked the breaker in the house. But of course, the electrician guy shows up, and she wasn't home. I don't know where she was, but she wasn't home when the electrician guy shows up. So the electrician guy figures, okay, well, no problem. I'd left the garage door open for him. Figured, okay, yeah, no problem. I'll just do it hot. And what happened was when he disconnected it, he broke the neutral bond. And that ended up throwing 240 across all my plugs. Loss of neutral, right? So, of course, while he's working on it, I think the freezer tried to kick in. And it blew up everything that was on the other side of the other phase. And this was one of the things on there. I lost a TV, I lost a satellite receiver, I lost an Astron power supply, I lost a ham radio that was plugged in because I had left it turned on. It was a repeater. It was a ham radio repeater that I had. So I lost a bunch of stuff, and this was one of them. And this one never got fixed. So let's see why it's not working. It's probably the power transformer that's blown on this. It's very likely the power transformer is open because I don't see any fusing. Right? I don't see any fusing. I see the power cord connected directly to the transformer. Right? So there's the power cord coming in, and it's as you can see, it's connected directly to the transformer. So in all likelihood, this transformer is gone, and what that means is I'm going to have to find another transformer that will work it. I'll have to figure out what the voltage is, but that shouldn't be too difficult because I would imagine that it's either going to be 6 or 12 volts. And that shouldn't be too hard to figure out because this thing has a regulator in it anyway. So we should be able to figure that out based on what the voltage of this capacitor is. But let's check it out anyway and see whether it is the transformer, which I'm sure that it probably is. So we'll put the meter in ohms mode and we'll just measure. And sure enough, it's open. Therefore, we know that the problem is the power transformer. So let's just cut this one out and try to find a transformer that will work. And I can probably get one out of an old wall wart. That's the idea. Now the reason this was never fixed way back was I didn't really need it. I used to use this mostly in the later years. I had it in my system. I had it in my TV system for a while. But where it ended up is it ended up in my ham shack. I was one of the guys that was into amateur TV or ATV. Going way back. And for anybody who's not familiar with what ATV is, no, it's not slow scan TV. It's fast scan. It's fast scan, like broadcast TV on the UHF band. We were doing it on 434.6, 439.25 in the ham radio band, using a television transmitter. I had 100 watts, I believe. 100 watt amplifier into I think it was a 16 or 18 element antenna, Yagi, and we used to beam our pictures back and forth from one house to another, and it was just like being on regular broadcast TV. right? It was. I wonder if there's a thermal cutout. I bet there's a thermal cutout on this, and that might be what's gone. And of course, I just screwed myself because I cut the wires off. But anyway, yeah, this was feeding the transmitter. I had this little. It was a little. Let's just say 100 watt. I could operate it on 439.25, which translated to cable channel 60. If you took a regular cable TV and you put it in cable mode, not broadcast, and you hooked up an antenna and you tuned it to channel 60, you could see the pictures, because that was one of the channels, was cable channel 60, but broadcast over the air. The other one that we used 434.6. 434.0 was the normal frequency, and 439.25. But we used 434.6 for the input. We had a repeater that would receive the signal and then rebroadcast it on a different channel. And then the one that it rebroadcasted it on was up on 1.2 gigahertz. So I had a receiver to receive, which was a satellite receiver basically, tuned to receive the down converted frequency, which would have been in that 1.2 band. It would receive the transmitter directly, so I could receive the output to the repeater, and I could transmit in using AM, or in this case it was vestigial sideband. We use VSB, the same as a broadcast station, on AM basically. But fun days, and I also have a 2.4 FM transmitter, gigahertz FM TV transmitter, 1 watt with a dish, and we use that too. I use that for remote stuff. We'd go out to a remote location and set up an antenna on a tripod, and then beam our pictures in to the repeater that was up on top of a mountain. So, well, fun days, you know. The amateur radio TV days were fun, and that, in fact, in my ham radio hobby, that was pretty much all I did. I didn't so much talk on HF or even talk on VHF that much. I was in the TV group, so we were getting our kicks out of sending pictures back and forth, and we'd go out and shoot stuff, go out and shoot scenery and stuff, and put our call signs and so forth on it, and just broadcast it, or sit in front of the camera and talk, just like today everybody's doing with Zoom, but we were doing it over the air. But those days are long gone. I would say probably most of the guys that were involved are all silent keys now, and if anybody knows what a silent key is, a ham will know. It means that the operator's passed away, so he's now a silent key, because obviously he's not going to be keying up anymore. But I'd say a lot of the guys were are silent keys now, and we lost the site for the transmitter, so that had to come down. So all the equipment's been packed away, but that's what this was used for. In its last life, this was used to switch the input to my TV transmitter. And then after this broke, I just started switching the cables back and forth. But as I say, when I had that major power problem, I lost a lot of equipment. I lost an Astron RS35, a 35 amp power supply. I lost an RC850 repeater controller. I lost a bunch of stuff. Thousands of dollars worth of equipment was burned up by an electrician's incompetence. And the guy that caused the problem, I still remember the day I was at work, and my wife calls me and she says, "You've got to come home." She says, "The guy's messed something up. I think there's a fire." She said, "We just went into your ham shack and it's full of smoke. It's like everything's like. I think there might be a fire in here. You've got to come home and check it out." So of course I go flying home there, and just yelling and screaming like an idiot at the electrician, calling him every name under the sun. And of course he's apologizing for all the problem. He goes, "Oh yeah, well our insurance will cover this. We've got insurance. It's not a problem." I actually did okay though, because I got my radio replaced that was blown up. It was $1,000 transceiver that was replaced under insurance, and I got the TV. I had a nice big 28 inch. Or is it 29 inch CRT set up in my shack that I use for the ATV stuff. And it got replaced. And when it got replaced with a 34-inch HD TV. So I did okay there. I mean, I certainly was able to get the equipment replaced, but it cost me, because what happened was the insurance company for the contractor, of course, denied any responsibility. You know, it had to be claimed against my home insurance first, and then it was going to be reimbursed. Like they paid me the deductible for the damage that they caused, and but I had to make the claim on my insurance. That was the only way they would do it. His insurance company. Oh yeah, it's burned right here. You can see the wire right there. See that wire there is just burned right there. There is no fusing on this transformer. You can see the wire melted right there. But anyway, this other one's probably not melted. Yeah, this other one's not. You see, this other one's going in. You can see it right there. But this one here burned right there. So this transformer's toast. Anyway, it was toast anyway. I was not going to repair a transformer with a shorted primary, because if it's popped there, chances are the insulation is melted off the winding and it's shorted internally as well. But anyway, yeah, where was it going? Oh yes, yeah, the way the insurance guys work is he caused the problem, but he's gonna pay it through his insurance company. But his insurance company says, well, no, what you need to do is you need to make the claim with your insurance company, and then we will reimburse you. And of course, the builder, he cuts me a check for the $500 deductible. And you know, once he's cut the check to pay the deductible, he's now in the clear. The problem that happened was the insurance companies got locked into a battle as to who was responsible, because his insurance company was coming along saying that the wiring in my old garage was substandard, which may very well have been the fact. I didn't build it. It was there when I bought the house. There was a cable feeding from the house, a 30 amp tech cable, and it just went to a junction box on the wall, and then from there it fed up to my what was my ham shack, but that was already there when I got the place. That wiring was already in place. It fed up to a breaker panel. So this was actually before. This was just a junction box, like a 4x4 junction box where the tech cable came from underground, and it was moretted. Like the wires were twisted. Like the wires were twisted together properly, right? They were twisted like that. Right? The bare wires were twisted like that, and they had a moret on them. But when the guy undid it, because the moret was on so tight, when the guy undid it, it started to untwist the wires. So then we had a gap, and that's what caused the problem, is the neutral. You know, had the power been shut off, there wouldn't have been a problem. And had I done it for him like I wanted to, I would have shut the power off before opening up the splice. But the electrician decided to do it hot. But then after he almost burned my garage down and blew up all my equipment, he denied any responsibility. And then, of course, it was the apprentice that did it. And the apprentice screwed up. And, it was a mess. The apprentice got fired. The electrician fired the apprentice. But in the end, all my equipment was replaced. But when I went to renew my home insurance, I had now made a claim. Even though it wasn't a claim, it was my fault. It was caused by an outside worker working for another company. It was still happened on my property. Therefore, when I went to renew my insurance, my rates went up. So that's a little story. Don't make a claim. Even if somebody else causes damage, make them pay. Don't claim it on your own insurance. Hindsight being 20/20, I should have said, no, I'm not making a claim on my insurance. You are going to pay me this entire amount, and if you don't pay me for the equipment that was damaged, I will see you in court. Right? Pay the $500 and get a lawyer to send them a letter, because you're going to pay that for your deductible anyway, and shake them up. But so in the end, it ended up costing me more, because of course I lost my claim-free status, and my insurance went up probably a couple $100 a year ever since, because I had to make a claim. Anyway, let's find a transformer. So one clue to what the voltage of this transformer is going to be is even though there's nothing marked there, but you can see the main filter capacitor, 1000 microfarad, rated at 25 volts. And it's discolored, so you know that this capacitor is probably blown, because when the power transformer got 240 volts going through the primary, well, the voltage on the secondary would have also doubled until it blew. So that cap is cooked. I don't know whether it cooked while it was running at high voltage and then blew up the transformer, because I don't know how long it sat at 240 until it actually burned out. It could have been there for several minutes. The regulator here would have taken care of it, so it should be no damage to it, because the regulator transistor here should have absorbed that excess voltage. But this capacitor would have been sitting at double its normal voltage there for a period of time, and it could have very well shorted, and then that's what blew up the transformer itself, right? Because the transformer would have had to get hot for it to fail. But anyway, we have a little insight here. It's a 25 volt rated capacitor, so this would probably be 12 volts or so, because a transformer running into a bridge rectifier, it looks like it's just got it's 4 diodes, so it's a full wave bridge. A 12 volt transformer will typically float around 18 or so volts. So this is going to be a 12 volt transformer. I'm trying to look through some wall warts that I've got and see if I can dig one up that will, I mean, I don't think it's critical. I could probably put a 9 volt transformer in here and it would work just fine. I don't think that's critical, but I don't expect that there's any damage to any of these ICs. You see, they did it right in this switcher, you see. They use mechanical switches to change inputs, but everything's done through switching these amplifiers. So they actually did it right, and this little switch actually worked quite well. Worked a lot better than the ones that were just a mechanical switch. Didn't have all the noise and stuff that a mechanical switch had. I found a small one here, and this might be a little bit on the small side, but it should power this unit up for demonstration. The unit's not going back into service, so I don't want to, destroy a good adapter that I could use for something else. So I just found one that should work. It's a DC output, so I got to open it up to take out the rectifier and turn it into an AC output. But it should, I would think, operate. I mean, for that matter, I could just connect the DC output directly to this. I could do that, right? We know the polarity because we've got the filter capacitor here, so I could just do that and just mount this inside here, glue it down inside the cabinet, and connect the two prongs here to the incoming cord. That actually would work, and that actually might even be even simpler than having to fiddle around with replacing the capacitor and so forth in here. I could just connect the wires directly to the circuit board and eliminate the need for using the bridge rectifier, because that's essentially what's inside here. That might make things a little simpler. Just solder the wires directly on with some heat shrink tubing, and then I can tuck this inside and connect the DC output to the main filter capacitor. I think we'll do that. That might make it a little bit neater a repair, and certainly a safer one, because then I don't have to worry about mounting the transformer. It's already mounted inside. So let's just open this up. We'll get some heat shrink tubing, and we'll connect the wires directly to the incoming line. Put some heat shrink tubing around there to protect them from short circuit and anybody touching it, and then we'll wire it up directly to the bottom. Pull the bottom off here. We can wire it up that way. You can get rid of this capacitor. It's not going to be necessary because there's already one inside here. And this is only, what is this one here? This is a 200 milliamp. This one might have been 300. So it should do the job. A little bit less voltage, but it should be okay. I think we're probably okay, because these circuits themselves probably aren't going to need any more than 5 volts. And as you can see, that is a 7805. That regulator. Come on, camera, focus. You can do it. You can do it. There you go. 7805. So 5 volt regulator. It should work fine. This is going to be floating probably around 12 volts. So that should be more than enough for this regulator to operate and keep voltage at 5 volts for all these chips. This one should fit over these terminals, no problem. So we'll just cut off a couple pieces of heat shrink tubing so that I can heat shrink the wires protect it from shorting out. And install the adapter inside the cabinet. We used to do this quite often on electronics. You know, someone's small device got blown up with a power surge, and you know, used just a 12 volt or 9 volt adapter, and rather than order a transformer from, say, Sony, where they would want, like, you know, $45 for a transformer, well, we could go to the shelf and pick up a plug-in adapter that was a $20 or $15 adapter, put it inside the cabinet, and then charge them $40 for it. Seriously, we did too. Yeah, we would do that if you know, a transformer like this from the manufacturer. A wall wart might run $10 retail, right? Costs maybe five bucks. A transformer like this from the manufacturer, same voltage, you know, same rating, transformer like this might run $30 wholesale from the manufacturer, and we'd be expected to sell it for $45. So what we do is we would go grab an adapter, put that inside, and charge them considerably less, and actually make some money on it, because when you ordered a $45 part and you had to mark that part up, you know, to maintain your profit margin, okay, now you're at $50 or more for the part, and you're adding another, you know, $50 labor. Okay, now you're at $100 to repair an item that's worth $100. So we would go and use a wall wart, wire it up, hot glue it inside the cabinet, and charge them $10 for the unit, or $10 for the transformer, the same price that it would sell for retail. Get our labor in there to do the work, and it was economical to fix. And then we used to do a lot of repairs that way that would allow us to fix something that otherwise would have been thrown in the garbage, and we wouldn't have got the repair out of it. So that was quite a common thing to do for small electronics, especially things like portable radios. That was the big one, like the portable ghetto blaster type things that had built-in transformer. The smaller ones, part costs as much as the whole unit. So there you go. It's as safe as anything. The metal terminals are completely covered with insulation or heat shrink tubing, which is insulated. So there's no chance of getting a shock from touching them. There's no chance of it shorting out against anything. And this can just be tucked right into the corner of this chassis, just like that. And it will sit in there quite nicely, actually. It'll sit down there just like that under the cover. So now let's remove the bottom cover so I can fish the wire through and connect it up. Oh, look, another item that's made in Taiwan, not made in China. For that matter, I can knock out this piece of the circuit board here. There was a piece, this is where the transformer sat over top of it. So this can be knocked right out, just like that. a jet engine firing up in my driveway. That would be the battery on my car charging up. Okay, I'm just going to shorten this wire. I don't need this wire to be 5 feet long. According to the markings on here, the wire with the white stripe on it is negative, so we'll just double check that, verify that I'm reading it correctly. See, I do have some side cutters, contrary to popular belief that some people believe that I don't own a set of side cutters. Actually, I do. I have a couple sets of side cutters, and then I got these ones, which I usually use. Yeah, and you see our floating voltage on this is 17 volts under no load, so no problem. And it is the negative terminal. Most of the time the one with the white stripe is positive, but as you can see on this one, the one with the white stripe is the negative terminal. So that's something to keep in mind, that not all of them, the white stripe is positive. We'll just discharge the capacitor in there and hook this up to the bottom. I'm going to probably remove this dead cap because this one here is all discolored. It's going to be no good. We'll make note of which way the polarity is. The negative terminal is to the side, so I can connect my negative wire to there. We won't need that cap because there's one built in. So let's just remove it. Looking at this thing, it looks like this thing's been repaired before. Look at the circuit board here. Yeah, that cap looks pretty dead. Okay, we'll bring our wires through the newly created hole in the board. And connect them accordingly. In the wires first, just to make the process a little bit easier, and then trim them back a bit. Okay, white wire is the one that's going to ground, which is, I think that's the shield over here. It should be ground there. Positive terminal is there, and this one should be ground. This one runs along and around where the back is, so positive terminal here to the we can confirm that this is indeed the negative terminal. I think I can see it back there, but we'll just confirm it. I'll put the terminal on here and verify that this is in fact ground. So I can connect my ground, which is the wire that's white with the white stripe. I can connect that over to here, because that's a ground point. And now when I turn on the power, this should light up. And I should have a working switch box, which we can confirm because I will plug it into my monitor and we will test it. It's got power. It's lighting up red. So it has power. I've connected two sources. I've connected my cable TV box and my color bar generator with an MP3 player feeding into the sound input. Let's observe what happens on the monitor. So first I'll select the input from my cable box.
200,000 people, so it is very broad, and
there
it was
it is.
based on
News channel.
clinical judgments from
I can put that on without having to
including
worry about
cancer
anything.
care and renal care under the auspices of the Provincial Health Services Authority. So that
and
is the
color bars.
associated with that high risk from this virus necessarily, but we still need,
There you go, works.
all in the concept of the people who are most likely to have severe illness or die. Particularly in February, we had almost
Our
nothing
news conference
several
for the whole
weeks,
COVID thing.
but through March and April,
They're telling us
As
they're
of the
going to get our second dose a lot
we've
sooner
now
now.
been able to ramp up. So all of those hundreds of thousands of people, we booked appointments for close to 500,000 people for second doses in the next few weeks.
So there you have an easy way to repair a piece of equipment that has a burned out power transformer if it's a low voltage device, like a 6 or a 12 or so forth volt device. It's pretty simple just to put one of these wall warts inside. Use some heat shrink tubing so that you're not going to make contact with your line voltage, and you're good to go. I don't even need to mount this. I don't even need to stick it down. I can stick it on with some double-sided tape, but this isn't going to go anywhere. It sits in there quite nicely, so when I put the cover on it, it will be good as new. So let's do that. These were made in days where they had real metal cases for things, not like today with everything being made out of plastic. Good as new. Oh, there's a couple little rubber feet here that have to be put around the cabinet. But as you can see, it's good as new. Works and looks the same. I know some would say, why don't you just put the wall wart, why don't you just lop off the cord and just plug a wall wart into the end. That could also have been done, wired it in directly, but then it doesn't look original. Now, the way it sits, put all the screws back in, and no one is the wiser that this has ever been serviced. Say we don't need this big filter capacitor because there's definitely going to be one inside that class 2 DC adapter, AC to DC adapter. That's it for this one. Thanks for watching. We'll catch you again in the next one real soon. Bye for now.